So we've talked about the first derivative. Now it's time to talk about the second derivative. Notation for the second derivative, very similar to the first derivative, but now we have a 2 involved. So we have y double dash, or 2 primes, f double dash x. Now with the d dx notation, the 2's, on the top it goes after the d, but on the bottom it goes after the pronumeral that we're differentiating with respect to. So it's d2 dx2 of the function, or the more common one, d2y dx2 is how we write it. Do not mistake it to thinking you're squaring the derivative. And possibly that's why the order of the 2's are like that, so it doesn't look like the whole thing's squared. d2y dx2 is the notation we use. How do we do it? Well, as the name suggests, it's the second derivative. So it's what you get when you differentiate it twice, for the second time. So 3x squared plus x plus 2, differentiate it once, we'd get 6x plus 1, that's the first derivative. Second derivative, do it again, we get 6. Something like this. We've got to remember our rules, of course, to do these ones. Square root of x squared plus 3. Got to change that to index form before I can do anything. Do not make the mistake of thinking, oh, I've already done some differentiation. It feels like you've done something. We haven't really done anything at this stage other than put it in index form. Well, we're going to have to use our chain rule. Anarchy. Bring down the power. Right. So bring down the power, lower the power, diff the inside, we get that. Let's tidy it up, the half times the 2x, we get x squared plus 3 to the minus a half. Now I could put that back into surd form, I'd get x on the square root of x squared plus 3. But I'm going to have to differentiate again. It makes more sense to leave it in that form, because now I'm going to have to use a product rule. Write down the first, diff the second, plus write down the second, diff the first. Write down the first, x, diff the second. But the second one, I'm going to have to again use the chain rule. So bring down the power, minus a half, lower the power, minus 3 on 2, diff the inside, 2x. Plus, because we're using a product rule, write down the second, x squared plus 3 to the minus a half, diff the first, or differentiate x, we just get 1. Let's tidy all that up. What have I got there? Well, the half and the 2 inside the square brackets there, that'll tidy up. And what will we get? Oh, of course, we've also got an x times x there. So there's x squared. Not much we can do with the second term, we're just multiplying it by 1. But now I want to factorise, and when we factorise, you take out the lowest power of the common things. Well, minus 3 on 2 would be the lowest number there. So let's pull that out. X squared plus 3 to the minus 3 on 2. What am I left with? Well, the first term becomes minus x squared. The second one, and if you're unsure, remember factorising is division. So if you went x squared plus 3 to the minus half divided by x squared plus 3 to the minus 3 on 2, well, divide, we subtract the powers. So minus a half minus 3 on 2 is to the power of 1, x squared plus 3 to the power of 1. Now we can tidy up the square brackets. Minus x squared plus x squared cancels. We now just have 3, and I have returned it to surd form. So on the bottom of the fraction we'd have x squared plus 3 to the 3 on 2, or 1.5. So it's x squared plus 3 to the power of 1 times x squared plus 3 to the power of a half. Power of a half means square root. There it is in all its glory, the second derivative. So our first example, a very, very simple one, where we just differentiate it very quickly. Second one, more involved. We've got to use our different rules. But I guess at the end of the day, what we're talking about here is we just differentiate again. That's all we do for the second derivative. So that's our second derivative.